Welcome to Rges Algebra 2. This is lesson 7A, and we will be covering 1.7F, 1.7G, and 1.8 in your text. Now 1.7F has to do with division by polynomials. We've already covered a polynomial divided by a monomial, and that's a very easy process for us. We just divide each term in the numerator by the monomial in the denominator, and so to speak, making it into a lot of short divisions. But the division by a polynomial looks much more like a long division problem, and so let me go ahead and walk you through that. Now, in many ways, I think actually dividing polynomials is easier than many times a long division, perhaps because usually the numbers you're working with are simpler. So I'm looking at the first one of my trinomial in my divisor, and I'm looking over here at the first term here. And what would I have to multiply a squared by to get 2a to the fourth? And the answer would be, I'd have to multiply it by 2a squared. Okay. Now when I multiply back, then I'm going to multiply each term of my trinomial and then subtract just as I would in long division. So let me do that. So the multiplication back is not too hard. The difficulty perhaps becomes when we are subtracting here, because these signs are always tricky for us. And I would have to subtract the second term, or the second expression, trinomial, from the first one under the division sign. And notice then that I'll have to really pay very careful attention to this, distributing this negative sign. Let me show you what I mean. 2a to the fourth minus 2a to the fourth leaves me with 0, and that's exactly what I would expect. If that does not cross out, I've done something wrong in my multiplication or my choice of my first portion of the answer above. Now, very carefully, when I'm looking at the next terms, notice my a cubed b and my a cubed b are the same, which is of course what they'd have to be before I can combine them. But as I'm looking at coefficients, watch what this does. -5 minus a -2. Do you see that? Because this minus sign out here has to be distributed through. So I'm really saying -5 plus 2 or -3. That's the trick. That's where most of your mistakes will be. Then in the next one, again, same idea, 6 minus 2. Well, that's a little easier. That's going to be 4a squared b squared. Now I'm going to bring down my next term, just as you would in long division. And I'm going to go up to find my second divisor above. A squared, now I'm looking at this term. And I'm saying, what do I multiply a squared by, again out here, just the first term out here as I'm multiplying, or figuring out the multiplier, and I'm going to multiply by -3ab. Because -3ab times a squared will be -3a cubed b, which is what I need. Okay, so now multiplying back all three terms, you get -3a cubed b minus 3a squared b squared, and then the third term minus 3a b cubed. Subtracting, and that again, this is the part you want to be very careful about. -3 minus a negative, that's -3 plus 3. That will cancel out. 4 minus a -3, that's 4 plus 3, 7a squared b squared. -4 minus a negative, that's -4 plus, 3 would be -1. And then again, when you're finished, you will want to go ahead and draw down your next term. I'm sorry, I got a little distracted there because as I'm looking at that, I noticed that I actually messed up a sign right here. So let me go back and correct that. Okay, so this was really supposed to be a plus because my minus 3ab multiplied by my second term, a negative times a negative is a positive. So then again, when I subtracted here, 4a squared b squared minus 3a squared b squared leaves me with just 1, not 7. Okay, I think negative, okay, plus that. Everything else looks good there. Bring down minus b to the fourth. Actually, the problem is supposed to be a plus, b to the fourth. Oh boy. So I'm showing you how easy it is to mess up these signs. And this is the problem with doing long division, is just being very, very careful with your signs. So I'm kind of illustrating what not to do. But what do I need to multiply this by to get this? And the answer is a b squared plus b squared. Distributing back to multiply by all three terms, I get a squared b squared minus a b cubed plus b to the fourth. Okay. Now, subtracting, I'm going to get these to cancel out. Minus minus 1 minus a negative 1 would be minus 1 plus 1. These will cancel out. And b to the fourth minus b to the fourth, these will cancel out. So I have no remainder in this particular example. And this is my answer up above, just as it would be in any long division problem. So it's laborious, and I'm not giving you a lot of problems, but you really want to be very, very careful as you're working on. Now let me show you one more concept with this before we go on to the next idea, and that is that sometimes not all the middle terms will be in place, in which case you have to insert them. For instance, if I have, let me show you, c to the fourth minus d to the fourth divided by c minus d, if that's my problem. Notice I'm not missing I am missing all those middle terms that I would want to have in place in order for this long division to come out. So I have to insert them, and let me show you how this looks. I'd put my c to the fourth, and now I've got to march down all those middle ones. I would want to go c to the third and just a single d. So my c's are going to go down each time, but my d's are going to go up. Now I'm so worried about that, I need my constant in there, and of course it's going to have to be a 0. C to the third d. Then 0, because it's kind of, I'm putting them in there as placeholders, would be the way you'd want to look at this. Now, 1 less on the c's would be c squared. 1 more on the d's would be d squared. Another one, placeholder. 1 less on the c's would be c. 1 more on the d's would be d cubed. And finally, 1 less on the c's and 1 more on the d's would be what I have in the original problem. And I want a minus there. Let me put a minus. Minus d to the fourth. Okay, so this, and this have been inserted as placeholders so that I've got something to bring down for my intermediate steps. So look at the example very carefully on page 28, and they show you that and walk through that whole problem with you. And I am only asking you to do some of the simpler ones and learn the technique in this lesson. Now the next concept is what we call synthetic division, and I really do think this is much, much easier, but it only applies when my divisor is in the form x plus or minus a constant. Okay, all right. And so when you've got a divisor of that form, you can do something that ignores everything but the coefficients, the numerical coefficients in front. So let's say I have the problem x to the fourth. Let me go ahead and write the whole thing out. So I'm going to pick up just my coefficients. This would be the same as 1 times x to the fourth. So I'll write a 1 plus 1 minus 3 minus 17 minus 30. Just my numerical coefficients. Now, my divisor is going to be the opposite sign of this. So rather than a negative 3, my divisor will be the opposite sign, in this case, a positive 3. So the technique will be bring down, multiply, subtract. Okay, so this is how it goes. The first one brings down to just a 1. 1 times 3 is a plus 3. I'm sorry, sum them, don't subtract them. Sorry. Sum them would be a plus 4. Multiply back would be a plus 12. Sum them would be a plus 9. Multiply back would be a plus 27. Sum them, so 27 minus 17 is a plus 10. Multiply back is a 30. And sum it would be a plus 30, sorry. And sum it, and that would be 0. And the last one is the remainder. Isn't that interesting? So you draw, it's a kind of a little bit of a tricks technique, okay? You draw the first one down without a multiply back, add. Multiply back, and what do I mean by multiply back? I'm always multiplying by this number here. And add. Okay, multiply back, add, multiply back, and add. And now to interpret this answer, you're going to take your x to the fourth up here and you'll go one less. So this will be, the answer will be x to the third plus 4x squared plus 9x plus the constant with a remainder of 0. So I'm going to show you a couple more of those. Okay, this one's pretty much the same, but we will have to, we notice we are missing a couple of our terms if we're going straight down and having to have each one in place like we did before with the long division, so we'll have to insert those. Recall we do take the opposite sign here, so my divisor will be 2. I have a 1 in front of the first term. My second term, my x cubed term, I have a 0. My x squared term will be a negative 3. My x term will be a 0. Notice how I'm inserting those. And my constant term will be a minus 10. Okay. Now, once you have practiced a few of these, this part of the technique works really very smoothly. Draw it down. 1 times 2 is 2. Take the sum. 2 times 2 is 4. Take the sum. 1 times 2 is 2. Take the sum. 2 times 2 is 4. Take the sum. Just like that. This is my remainder over here. So to interpret this becomes 1 less than the original term. This will be x to the third plus 2x squared plus x plus 2, all those positives, minus 6 over the divisor, the original divisor, x minus 2. And that's all there is to it. It's actually a pretty swift little technique here. So we are going to skip 1.FH. We'll be picking up some of that later. And let's go on to equations 1.8. The first part of 1.8, solving equations, I think you're very familiar with. If you'll turn to page 33, this is actually quite a bit of review from Algebra 1, so I would like to just talk you through some. The example 1 on 1.8, page 33, make sure you have your text in front of you. Go ahead and pause it until you do. Notice what I would do. Just look at the problem. I would distribute, then I would gather like terms on the left. I would move my x term to the left, my numbers to the right, and do my final multiplication or division. For the second one, the problem looks like this. I would move my x term to the left, my constant to the right, and then I would do a division. You're going to be very careful about your signs, of course. Let me look on the next page, see if there's anything that seems disconcerting to us. I think almost all of this is very straightforward. Don't panic if you get to a few fractions. Just hold yourself steady, and then the only other thing would be sometimes as part of your expression you might come into something like that as just part of a much longer equation, where that would be a squared. Just recall that you can either remember the pattern or just simply write it out and FOIL it. Either way, right? Those patterns will come quickly back to you. Now, on the next page, I want to talk about absolute value because, of course, even though you've been covering that some already this year, that is more difficult. So, the rule for this will be you will isolate the absolute value expression on the left-hand side and then turn it into two different equalities to solve. So let's go ahead and do that. We'll first subtract the 2 from both sides. And so that'll be 8 minus 2, or 6. We'll divide by 2. I want to isolate my absolute value expression on the left-hand side. So 6 divided by 2 is 3. At that point, you spread this into 2 equations. You'll take what's within the absolute value sign, and you set it equal to what's on the right side. Nothing changes for the first equation. For the second equation, you take what's in the absolute value sign just by itself, but now it equals the opposite. Not 3, but -3. And I've explained several times why that is the case. Think back to your number line. Solving each of these, I'd add 1. So divide, and that's my first answer, or adding 1. -3 plus 1 is -2. Divide equals -2/4 or -1/2. So my answer would be these two solutions right here. Okay, I don't think I'll do any others on that because you definitely have had some practice, but if you struggle with the answers, we'll go ahead and do them together again in class.